In this video, we will learn about the built-in data structures in Python. So far we've been focusing on the simple types such as integer, float, complex, boolean, and string. And these types allows us to store single values in a variable. Now many often we want to store a bunch of values in a variable. And this is especially true when we process data in data analysis tasks because we usually have a bunch of values that we need to process. For instance, student grades, customers' informations. It always comes in multiples, and we would like to apply the processing that we do on all of these values. Now we have actually seen one type that allows us to store a list of values, and that's the list type. And the list type allows us to store an ordered collection of values. And now those values can be from different types. And those values come in sequence of being listed in the list, and the list starts with one bracket, ends with another bracket. We actually seen the tuple or the tuple data type, and we've seen it when we used functions. When the function returns multiple values, those values will be packed in a tuple. Now the list and the tuple are very similar. The only difference in between them is that a list can change, the tuple may not change. So we will see that important difference in a minute. So that's why we usually use list almost 90% of the time, because very often we would like the values to change. The third type is called a dictionary. Now the dictionary, in contrast to a list, is not a sequence of things, it's a sequence of associations between two things. And each one of these associations is an association or a mapping between a key and a value. So in this example here, you can see that the dictionary is associating A as a string with number 1, B as a string with number 2, and C as a string with number 3. And those associations are indicated with a colon here, syntax. And the dictionary is created by listing these associations in between two curly brackets. Lastly, we have the set, and the set stores unique values. So in contrast to a list where you can repeat the same values many times, in a set you cannot, and actually if you do, the repeated values will be taken out. So it only keeps a collection of unique values. Now one note about the dictionary and the set: they are unordered, meaning that the order of the items in the dictionary and the set is not guaranteed to be following any natural ordering. Now it's important to note here that an order doesn't mean it will not be provided in a certain order. It will be ordered somehow, but that ordering is not guaranteed, so we should not rely on it. So many of the time when we create a set of numbers, we will see these numbers put in an ascending value. But we should not rely on that being the same across different instances of running the same notebook or across different machines. However, a list and tuple are ordered, and meaning the sequence of listing these items in the list or tuple is guaranteed to remain the same. Let's take a look at each one of these types in more details. Here is a list. Now, the list in here is created by listing the values or the variables which we want their values to be listed in between two square brackets with commas in between. If I do type L, I'm gonna get list. The len function, the length function, can operate on any sequence, including a list. A list is a sequence of values and is going to give me the length of the sequence, the length of the list in this case. So len L in this case will be 4. Now again, as a data type, the list provides many useful functions, and all of the functions can be known by checking the documentation or invoking code completion. So press dot and hit tab, and you're going to get a list of these functions here. So we've seen the function append before. The function append simply will take one value that we pass it to the function and is going to append it to the list. So for instance, if I do l.append 11 and then take a look at L, I see that the value of L has changed. We have seen that we can concatenate two lists together. So for instance, if I concatenate L plus 13, 17, 19, I get this list. Now it's worth noting that the function append has a side effect. So the function append doesn't change the list, it actually changes the list, it doesn't return a new list. However, concatenating two lists doesn't have a side effect. If I take a look at L, L hasn't changed. Adding a list to L is basically just creating a new list that I can basically read back and store in another variable. So if I want to keep this, I can do L2 equals to L plus that, and then I take a look at L2 and that's the new list. Another function, useful function, is the function sort. L.sort will basically sort the list in place. Now this function is very similar to the function sorted, a function that we have seen last time. And the function sorted sort any sequence, including a list. It's worth noting that sorted doesn't sort in place. It actually returns a new list that can be sorted, and keeps the original list intact. If I take a look at L, L is still the same here. Actually, let's shuffle L a bit here. Let's sort this one. Let's sort L2. So that's L2. Well, L2 is sorted, so I'm going to just make it the opposite here. Okay, so if I sort L2, you can see that L2 did not change here. However, sorted returns a new list that I can assign it back if I wish to another variable, let's say L3 in this case. So it's important to note that sorted doesn't have a side effect, it just returns a new list. Okay, let's take a look at the function sort. Sort sorts in place, so it has a side effect. It doesn't return a new list, it basically sorts the list that we want to sort, which is sometimes more efficient if we have a long list, because sorted, simply speaking, is recreating the list. Sort is just sorting it in place. That said, sort has the same options as being able to provide a key function if we wish to determine how the sort operates. Finally, a list in Python is not limited to one type. We can combine, mix and combine types, such as we can see here, we have number 1, 2 as a string, 3.14 which is a float, and we actually have another list. Because list is any value, it's like any other value. It's a value of the type list. It can be an element in another list. Hence here we have a list of multiple types, including list, which makes it a nested list in this case. So nested list and nested data structures are very important because many of them are used to represent hierarchical data. And we will see plenty of examples of using these nested lists in this course. Let's talk about list indexing and slicing. So we would like to process elements in a list, and a basic operation to process elements is to obtain, to pull, to extract these elements from this list. The process of extracting an element, accessing an element in a list is called indexing. Python provides two operations for that, indexing and slicing. Indexing extracts or accesses one element, and slicing extracts or accesses a slice or multiple elements in the list. Let's start with indexing. In Python, sequences are indexed using a zero-based index, meaning the first item is the item at location 0, and the last item is the item at location length -1. In this example here, for instance, if I do index, and the index operator that we have seen before is used with a 2 square bracket, and the index itself in between the 2 square bracket, L at 0 is going to give me 2. because that's the first element. L at 1 is going to give me 3. 2 is going to give me 5. 3 is going to give me 7. And 4 is going to give me 11. It's very important when we do index not to go outside of the index. So if I do L at 5, I'm going to get an index error because this number is out of range. Okay, so the number has to be in between 0 and length minus 1 for it to be a valid index. So many often, and this is something you've probably done before if you've used Java and you've used arrays in Java, to get the last element in an array, such as similar to a list here, we do something like this, length minus 1, and that will give us the last element in a list in Python. Now Python has a nicety, which is being able to index with negative numbers. When we index with negative numbers, we go backward. So if you want to get the last element in the list, instead of typing this expression L length of L minus 1, we can simply say L at minus 1, and that will be the last item in the list. L at minus 2 is going to go backward twice and get us number 7. This is a very handy feature because it circumvents just needing to do this kind of complicated and cumbersome operation. And it's very intuitive to see when we visualize the list as a list of items. So that's the position at 0, 1, 2, 3, 4. If we go backward, 11 is at location minus 1, 7 minus 2, minus 3, minus 4, minus 5. So the first element in the list is basically the element at minus length of L. Of course, we don't do that because if you want to get the first element, there is no need to go backward, we can go forward. It's basically the same element at location 0. So we don't do it. We use negative when we go backward, we use positive when we go forward. Alright, so let's talk about slicing. Now, indexing is giving us access to one element in the list. Slicing, on the other hand, is giving us access to multiple elements in the list. And a slice starts with a certain position and ends at another position. Now, the slice is also zero-based, and we're using the same zero-based indexing. The caveat here is that the start of the slice is inclusive, the end of the slice is exclusive. So for instance, if I do a slice from 0 to 3, that's going to give me item 0, item 1, item 2, but not item 3, because item 3, the end is exclusive. So I'm going to get, in this case, 2, 3, and 5. Now, if I am slicing from 0, 0 is optional. So I can do slice from the beginning. I don't need to put 0. It's implied if I don't put 0 to the end. Now, obviously, you can slice from another position. So let's say I want to slice from number 1. I will get slice from 1 to 3. It's going to give me 3 and 5. The point in here is that if we are slicing from 0, we don't need to put 0. Here is another slice here. This slice goes from element minus 3 to the end. Once again, if you don't put the end of the slice, it's going to be the end of the list. So if you slice from element number 3, it's going to be here. Number 5, you will get 5, 7, and 11. It's worth noting that here, if you're slicing to the end of the list, you don't put minus 1, because if you put minus 1 will be exclusive and you'll get a different slice. You'll get 5 and 7 because minus 1 is exclusive. If you want to be really specific here, you put length of L, because length of L will be exclusive, so you end at length of L minus 1. That said, the beauty of slicing is that you don't need even to put this one if you're going to the end. You just put nothing and it will by default goes to the end. Now a slice also has an optional step. So it has the start and the end, but you also have the opportunity of providing an optional step. By default, it goes one by one, but you can change this. Let's take a look at this slice. This slice starts from the beginning, ends at the end, but goes 2 by 2. So it will go to extract element 2, skips 3, extract element 5, skips 7, and then it goes to 11. So you will get half of the list. This is a very nice feature because many often we want to sample our data and we have, let's say, a list of 1,000 elements, and let's say I just want 10% of these elements. So I do a slice with a step of 100, I get 10% of that because I skip each 100 element in my list. The step is also very useful because it allows us to use a negative step. And this is now starting to be mind kind of puzzling. What does it mean? It basically means you're going backward. So when I do such a slice, this slice is interpreted as going from the end to the beginning with a step of -1, and basically goes 11, 7, 5, 3, 2. And it basically gives me a new list, which is the reverse of the original list. So slicing will require some practice and exercise for us to internalize it. It's one of the most useful features in Python, and it not only it applies to list, as we will see, it applies to more sequences than list, such as string. But even more importantly, the same concept will be extended in pandas, the package that supports data management, advanced data management operations in Python. So it's really important to understand slicing, really important to master it on a list before it gets more complicated when we talk about data frames and series. Now, both indexing and slicing can be used in read and write mode. So far we've been just accessing items, but we can basically change the value of these items. Whether these items are single items when we index, or whether they are slices when we do slicing. So in this example here, I'm changing my list. Taking the value 100, store it in position number 0 in my list. So when I print list, I can see that the first element has changed. Similarly here, I'm changing the second and the third element in my list. So that's the slice 1 to 3 is basically giving me 3 and 5. Right? And I'm saying, okay, 3 and 5 now will have the values 55 and 56. And this will change the underlying list here. So that's to say that we can use both indexing and slicing to access, but also to write into the list. Alright, let's talk about tuples here. Tuples are very similar to lists. The only difference syntactically is that they are defined with 2 parentheses rather than 2 square brackets. And actually the parentheses are optional, so if you start listing values with commas, you get a tuple by default. And this is something we saw when we did function, when we did return multiple values, and those values were packed in a tuple. So this is a tuple T, has the element 1, 2, 3. That's exactly the same tuple here, without the parentheses. Now if I do type T, T is a tuple. Length of T is 3. T of 0, very much like a list, is going to be 1. 2, 0 to 2 is going to be a slice from the tuple. It's going to give me a subtuple from 1 to 2. What's the difference in between a tuple and a list? The difference is that the tuple is immutable, meaning it doesn't change. If you try to write into the tuple, you will get an error because we cannot change the values in the tuple. So in that sense, the tuple seems very restrictive. Why do they exist? Well, they exist for 2 reasons. One of them is that many often you want to define something that you don't want it to change. The second reason, they're more efficient because Python knows their values do not change, so it stores them in a more compact form, and they are more efficient to store and process than lists. Let's take a look at dictionaries. Dictionaries are basically associations. In other languages, those are called maps. So if you're coming to Python from Java, you've probably heard of map and hash map. The dictionary in Python is kind of like a map in Java. Basically stores a mapping between keys and values. And those mapping are represented with associations using the colon operator in between values or variables. And of course, we use the two curly brackets to list these associations. Now you can think about, once we have a dictionary here, there are different ways to access a dictionary. The most common operation is to extract a value associated with a key. So if I do numbers, which is the name of my dictionary, bracket 2, that's going to give me the value associated with the key 2. Now this is very, you can see that the notation is very similar to the list. And actually you can think about conceptually a dictionary is kind of like a list, but instead of having the zero-based index, the default index, you're giving it your own index. You want to index 1 using 1 as a string, 2 as a string, and 3 using 3 as a string. And then you can access it in read mode by indexing it using the key. And similarly, you can write into it. Let's say you want to write a new key value associations. For instance, 90, you can do numbers 90 and you get a new key value association here. The dictionary also has many functions. Some of these useful functions are the function keys, which basically gives you kind of a list of the keys if you want only to take a look at your keys. The function values, which basically gives you a list of values. I'm saying a list of values, it's not strictly speaking a list, but you can think about it as a list. It's of the type dictionary values, but it's also a sequence, very much like a list. So we can treat it as a list for all purposes. And if you want to convert it to a list, what you can do, you can just force convert it to a list by passing it to the list function, the list constructor here. That's if you want to convert it to, strictly speaking, being a list. Okay. And the last useful function is the function called items. And this function creates a list of tuples in between the keys and values. So we will see use cases of these functions in the exercises. And there are many of them. Okay. All right, so let's take a look at sets. Now, set is very much like a list in the sense that it only stores values. It doesn't store association like dictionaries. The difference is that a set doesn't allow us to store repeated values. It only keeps unique values in the set. The other characteristic of the set is that the ordering is not guaranteed. Now, the items will be ordered somehow, but we shouldn't rely on this ordering in our code. Let's take an example here. Let's say L is equal to 2, 3, 3, 4, 4, 2. This is a list, and you can see that it lists the items in a sequence. And if you repeat the same item, that's not a problem. The item can be repeated. Let me create a set. And I'm going to copy paste the same thing here, except that instead of using square bracket, I'm going to use curly brackets to indicate it's a set. Now also pay attention to that the curly brackets syntax is also shared among a set and a dictionary. How does Python know it's a dictionary versus a set? Well, it knows that if it's a dictionary because you're putting here associations. There is something colon something else. Hence, it knows that's a dictionary. If you just list values or variables without associations, it's going to know it's a set. And obviously, you cannot mix and match. You'll get an error here because you have to make your mind. Either you list values or you list associations. Okay, so if I list values, I'm going to get a set. What's type S? Type S is a set. S is a set. Okay, so what's inside S? Oh, we only have 2, 3, 4. What happened? Well, even if you list some repeated values in a set, or even if you change the set down the road by adding elements, a set keeps only the unique values in it. So it's also possible to add new element to a set. So for instance, you can add 6 here, and set will have 6. But if you add 4, it's not going to add 4 one more time. Okay, so the set only keeps unique values. Now this is a very important feature of a set, and very often we use set to basically filter out repeated values in a list. For instance, if I give you a sequence of grades in my course, that's the sequence of the grades of the students, but many students will share the same grade. For instance, well, many students will have A, A minus, B plus, B, and so on. If the question is, so what are the unique grades that you've got in your course? Did you get any C, for instance? Did you get any D? Did you get any A? What we do usually is we take the list of the things and we pass it to the set constructor to make it unique. Let's take a look. For instance, let's say I have 10 students and I've got A, B, B plus, C, G, C, A minus, and B plus. Did I get 10? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here is a 10. Okay. So those are the grades of the students. If the question is, so did you get any F in your grades? What are the unique grades that your student have? To filter out the unique grades, what we usually do, we convert the list to a set using the set constructor. So if I do set of grades, I'm going to get a set of these grades, and the set of grades contain A, A minus, B, and B plus, C, and D. So those are the unique values in my list. So that's one very common use case of a set. The other benefits of set is that, as the name implies, it's a set. So we have access to the set operations. You may have learned about set operations in basic math classes. If you remember Venn diagrams, overlapping between two sets, the union of two sets, intersection of these two sets, those are basically the set operations. Let's really take a quick look here. Let's have two sets. One is prime numbers and one is some odd numbers. Okay. Union is basically items appearing in either. So you get all primes and all odd numbers here. Intersection is the intersection. The item has to be appearing in both. And once again, in each one of the operation, we have an operator, but we can also call a function such as union or odds. We don't need both of them. They're just listed here for illustration. So I can either do this one, or I can call the function union. Okay. So same thing for intersection, either using the operator and or call the function intersection. Either way, we get the intersection. Difference is the items in primes but not in odd, either with negative or with the function difference. Symmetric difference is the items appearing in only one set. So in this case, prime symmetric difference, odd is going to be 1, 9, 2. So those are the numbers appearing in prime but not odds, but also the numbers appearing in odds but not prime. Those operators are important in this stylistic example. They're just kind of for showing purposes. But many of them, for instance, we have let's say a list of customers who made a purchase in 2019. And we would like to know whether they made a purchase in 2020, for instance. If not, maybe we want to send them a reminder or a brochure or a discount, something like that. So being able to detect how two sets of things relate over two cross sections is a very common operation, data analytics operation. So this concludes this summary of the built-in data types in Python. They're very useful for basic data operations, and the more advanced types build on these types. So next we will get some practice